All right, for this next example, the phrasing of the question sounds fairly similar to the last example we did. This time, though, it says find the volume of the solid outside the half cone, z equals square root x squared plus y squared, and inside the sphere, x squared plus y squared plus z squared equals 9 this time. So the same cone, a slightly different sphere, and then the region is going to change. So let's try and graph what these look like. So the cone is the same cone that we were working with last time. So we can draw it again up here. It's that upper half cone. And then our sphere this time is an even easier one, where it's the sphere with an origin, or a center at the origin, and a radius of 3. So we're going to have this guy for our sphere. So if we really take a look then at what we're looking for here, well, we've got this curve of intersection of the two. Now, last time we wanted to be above the cone and below the sphere. This time what we want is we want to be outside of the cone and inside of the sphere. So if we try and picture what that would look like, well, that means that we need to be outside of the cone, but still inside of the sphere. So essentially we want most of the volume of the sphere, but minus the volume of that portion of the cone that intersects it. So really what we're looking for is like this. We're kind of trying to find the volume of that sphere minus that part of the cone. So again, let's try and think about doing this in spherical coordinates, since these two equations are going to be nice to represent in spherical coordinates. We already found last time, so we found in the last example that when I did z equals the square root of x squared plus y squared in spherical coordinates, that was the equation phi equals pi over 4. So you can see that in the previous video if you don't remember that one. And on our sphere this time, we just have x squared plus y squared plus z squared is going to be rho squared, and then it just equals 9. And then remember, that would mean then that rho is plus or minus 3. But then since in spherical coordinates rho is strictly greater than or equal to 0, we're just going to have rho equals 3. So we just have rho as a constant being the formula for the sphere. So now let's think about some bounds for rho, phi, and theta for the solid that we want. So for rho, we're thinking about, okay, what do we need the radius to go between? Well, if we pick some spots in this sphere, well, we need to go from the origin all the way out to the edges of the sphere. Even right here when we intersect the origin, it really comes all the way out to the sphere. So rho is going to go from 0 to 3, which is our sphere in this case. Phi then is, again, it's that angle that we need that line segment to make with the positive z-axis. So if we picture it this time, we want to be outside of the cone and then continue working our way down from there when we swing it. So really we're going to start at phi equals pi over 4. And then we do have to be careful. Don't forget, with phi for spherical coordinates, it only ever goes to the negative z-axis. It just goes to phi equals pi. So we don't go all the way around to the other half of the cone. We just go down to the negative z-axis. That's as large as phi is allowed to be in spherical coordinates. And then what we need is we essentially then have kind of this slice that kind of comes from the cone and then comes down. So it's sort of like this wedge piece, and we need to see, well, how far around do we want to let it swing when we move this kind of spinning in that theta direction. And we see that we need a full rotation of theta. We want to go all the way around the sphere, so theta is going to go from 0 to 2 pi. So really the only main difference in this one compared to the last one is my sphere has a different equation, so we have rho goes to 3 instead of something else. But then phi, rather than giving us the angle that's inside of the cone, we used phi values that would have us be outside of the cone, so going from pi over 4 to pi. So now when we create our volume, we're going to go from, let's do theta first, so theta is 0 to 2 pi, and then phi is pi over 4 to pi, and then rho is 0 to 3. And then this goes, remember we need a rho squared sine phi. Normally, if it was rectangular coordinates, we would integrate 1 to find the volume using a triple integral, but because we've switched to spherical coordinates, we need that factor for spherical coordinates. So we've got that rho squared sine phi, and then we did this d rho, d phi, d theta. So let's take a look at finding that volume. We're going to have 0 to 2 pi. We'll have pi over 4 to pi. We're doing a d rho integral first, so we'll have 1/3 rho cubed sine phi. And we evaluate that from 0 to 3. This is d phi d theta. So then we'll have 0 to 2 pi, the integral pi over 4 to pi. We're going to plug that 3 in, so we'll have 1/3 3 cubed, which is really just 3 squared, so 9 sine phi. And then plugging in 0 just makes 0 times sine phi, so it'll all cancel out. So then we're d phi, d theta. Plugging that in, we get 0 to 2 pi. We're going to integrate with respect to phi. So the integral of sine with respect to phi, sine phi would go to, let's see, negative cosine phi, and then that would really be negative 9 cosine phi. We'll keep that 9 there. We'll evaluate that from pi over 4 to pi, and that'll be d theta. And then cosine of pi is going to be negative 1. So we'll have negative 9 times negative 1 will be positive 9. Cosine of pi over 4 is square root 2 over 2. So then we'll have minus 9 square root 2 over 2. And this is all from 0 to 2 pi. D theta. So then we're going to have 9 minus 9 square root 2 over 2 all times theta evaluated from 0 to 2 pi, which we then will get 9 minus 9 square root 2 over 2 all times 2 pi all minus 0. So then we'll get 18 pi minus, the 2's in the second half will cancel out, so we'll just have, I dropped a negative, excuse me, because it would be minus a negative 9 way up here. So when we plugged in pi over 4, we plugged that into a negative, but we were subtracting it, so really this is plus 9 square root 2, and then we'll have plus 9 square root 2 over 2 and plus, so this is a plus. Sorry about that. Hopefully you can follow my correction there. So then when we multiply the 2 pi through there, the 2's will cancel, so we'll just have 9 square root 2 pi. So 18 pi plus 9 square root 2 pi is my final volume for that portion outside of the cone and inside of the sphere.